Okay, hey everyone. I know this is really delayed, like it's the day after the maths paper, and people are sitting Irish paper 2 at the minute. So I know I'm very delayed, and I know there's solutions have already gone up by some channels, which I think directly after the exams is a little bit like crushing in a sense. You know, if some people had certain answers and then the people who were doing the quote unquote solutions give a different answer, that gives unnecessary stress, which is why I'm tending to do all the solutions after all the results come out. So anyone who's looking at solutions at the minute, I wouldn't recommend doing it. It just adds undue stress. Now, after that little PSA, it's now time to review the paper. Not necessarily give numerical answers, but again, just give my thoughts and opinions on this second paper. I definitely think this one was a lot nicer compared to paper one, which is what we were kind of expecting. Because paper one was a bit rougher around the edges. This one was slightly smoother, but definitely thought there were a couple of um, difficult bits. Now, question one wasn't too bad. We got a stem and leaf back again, so this appeared in 2024. We weren't expecting it to come up for another while, but I mean, here it is, and it's asking you a couple of pretty easy things to find out. So the mean, range, and interquartile range are terms you should be familiar with, or should have been familiar with. But then a pie chart came up, which I can't actually remember the last time it came up. It's typically an ordinary level question because there's more pie charts than ordinary. Um, but still something that you should have been pretty capable in doing. Just splitting the uh, data, so 360 divided by the number of entries gives you a single entry. Um, and then you just put it in each of the different classes. So not actually too bad of a question. Um, and then part C was a little bit of a thinker, but I mean, there's not a lot of space, so you didn't really need a lot. But once you've cracked it, it's pretty nice marks. Okay, uh, question two, a question about confidence intervals using the margin of error approximation. That was pretty nice. Setting a confidence interval, you should be 100% confident in setting up a confidence interval. And then setting up a pretty straightforward hypothesis test. They actually gave you the null hypothesis pretty straightforwardly. So the alternative kind of follows on from that. And then talking about more so the theory end of the p-value. So if you knew the p-value formula, you could realistically find the corresponding z values and work at it that way, or just noting the what the p-value means definitionally, which is a common enough question you should have seen in some previous exam papers. Now, this is where things get a bit strange. Question three is talking about actual symmetry. So it is a pretty okay construction, but I know a lot of students weren't expecting construction. Well, by construction, I mean in terms of the circumcenter and the orthocenter were the two that had come up a while. Obviously, centroid came up in 2024. We weren't expecting actual symmetry or really anything like that, so it's a bit strange. Then the part B after it was pretty nice. It's just subbing into a formula. You'll get some cubic equation, and everything actually works out pretty nicely there. And then part C again required a little bit of thinking. However, this hint actually solved the entire question for you because it would actually tell you what the radius, or sorry, what the diameter of the corresponding sphere is, and you can work with it that way. But I do get it if students might have spent possibly unnecessary time on this question because it is a little bit difficult to visualize, even sort of with this hint. Question four, identifying perpendicular lines, just using the definition. And then part B was a nice, somewhat conceptual question about a line intersecting a range of values, which, yeah, the diagram you pretty much need for it to sort of visualize kind of what's going on here. But a very nice question nonetheless. And then a pretty standard perpendicular distance question. So I think in terms of how they're going to distribute the marks, I'd say probably 20-25 marks would be spent on A and C. Whereas part B, like the maths in it is not difficult, but trying to visualize it is somewhat difficult, I would imagine, for most students. So I'd say the marks will be adjusted sort of accordingly. Question 5, a circle, center and radius, really nice question. And then this sort of somewhat awkward mix of probability with coordinate geometry of the circle, which, I mean, if I were picking two questions, that would be unlikely to come up, but maybe apart from like geometry and statistics or something. In terms of Euclidean geometry, because I know pie charts, but sort of you get what I mean. I wasn't expecting probability and coordinate geometry to come up. Well, coordinate geometry is circle at least, because the one with the line, one of those actually came up in 2024. But we weren't expecting the circle to show up in tandem. Though, actually, pretty straightforwardly, you can actually just create your own equation here. And then two different conceptually difficult questions. This part 2 it's fairly okay. It is just a combinations question, but parts 3 and 4 might have been a bit difficult. This one, obviously, all the numbers have to be the same. And this one, I haven't actually spent a lot of time in it, but my first inclination with this one is also that all the numbers have to be the same. That's the general equation for a circle which is tangent to the two axes. And then this question also did require a little bit of thinking. So overall, a slightly awkward mix of questions for that question 5. But if you spent a decent amount of time on it, you probably should, well, not probably, but hopefully could have cracked it. Question 6. Theta is acute, sine theta equals a quarter, and we need cos theta. Really nice question. You just set up a right angle triangle. And then if we're given the graph of cos squared and to draw sine squared, again, this hint was really, really useful. The fact that cosine squared a plus sine squared a is equal to 1. Of course, you can make all the points that just add up to 1. That was pretty straightforward. And then a mandatory trig proof, which they actually gave the diagram for, which was pretty handy. So overall, my thoughts on the short questions, definitely the first 2 would be ones I'd say everyone in the country answered, because they were really, really nice. There were no major sort of pitfalls with questions 1 and 2, but a lot of the later questions, maybe apart from this one, maybe apart from question 6, so say 1, 2, and 6 would be the first ones that I'd answer, and then it'd probably be a toss-up between 3 and 4. But no, there's a wide range of difficulty in those short questions. Now time for the long questions. This one is about triangles and sequences. I'm pretty sure there's something with sequences kind of in there. I looked at this on Monday, kind of when it released, but didn't have time to make a recording, which is why I'm only doing it now. Area of a triangle is fine, and find the value of x. That's just using the cosine rule. So that's not terrible. Stuff you should have seen before, and there'd be bulks of marks on for those 2 parts. And then here, again, finding the value of y. Here it's probably easy just to use the sine rule, though I could see if you've used, well, the cosine rule wouldn't really work, so I'd say sine rule would probably crack that. And then part 3, bit of a nice question, actually, sort of combining Pythagoras' theorem, because of this angle being a right angle. And all 3 sides, you can just square them. Square all the sides, square this, and add it to that squared, and everything should hopefully cancel nicely and get you a pretty easy quadratic. And then another conceptual question. They're introducing a lot of these now, where it's not necessarily compute this or compute that, but rather what happens to a particular quantity as it goes to something else, or that kind of sort of imaginative end of mathematics. This one, it was actually pretty, it's a pretty nicely worded question. Just with regards to, obviously, if you make n increasingly large, which I thought was pretty nice. And then we have similarity and congruence. Well, actually non-congruence, but similarity in a sense. Which is, again, the only way that I can actually see this is somewhat through brute force. But I wouldn't be surprised if there's much easier methods. So overall, a bit of a nice question, just involving some decent bits of trig. Not necessarily to do with sequences, but to do with sort of that integer restriction, which is something they don't do too frequently. Now, question 8. Now, I've mentioned that question 7 was nice, but I think question 8 was even nicer. So, a pretty straightforward start about correlation coefficient, just how correlate this data is. And then drawing some lines of best fit and sort of interpreting it. So, these 4 parts, really quite straightforward. I'd say probably 15-20 marks just on this. Part B. And then part C, some probability, although using the common things that come up, such as, well, in this case, the at least once. We were expecting probability to be a slightly bigger part of the paper, but it's just seemingly this question, and I think there's one more in question 10 with inferential stats. It kind of pops in there. But not too bad of a question once it's properly interpreted and all the numbers in there are interpreted correctly. Then we have a trig function. So not actually too bad. Just noting that t is after 21st of March. So for here, 28th of March would be t equal to 7, for example. Okay. And then part 2 is just solving a trig equation. Now, note that anyone who tried to run through how many days were after the 21st of March, I mean, there's no extra credit here, but I probably would if I was having this as, say, not a mock test, but like a Christmas test or something. I'd probably say you'd get like an extra mark if you found the extra day. But a definitely nice mix of questions, and I'd say probably over half the marks are going towards the correlation. Okay, question 9. Again, with some congruence and sort of looking at different triangles, though this one wasn't actually too bad. You just need to find 3 things that are exactly the same between the top triangle and the bottom triangle, which are pretty easy to work out. Yep, and then some pretty okay Pythagoras, or SOHCAHTOA even, just for the fact that the line AD is tangent to both K and S as well as B and C. They're both tangents. So you can work with right angle triangles here, and then using similar triangles, though note that the length of the belt is cut from A to B. So you do a sector going from A to B, then you do the lengths B to C, and then A to D, and then the sector going from C to D. Just as kind of a brief thing, like I'm not going to run through the calculations or anything, but that's roughly how it would go. Then a pretty classic question involving folding up a box of different lengths. So definitely one you would have seen before and done plenty of practice of. And then question D, trapezoidal rule decides to show up. Now, obviously, we don't have the strip length. We only just have the heights. However, this length here, that 8.8, you can spin around for the fact that A to B is the arc of a quarter circle. So that's the radius, and you go, and that actually gives you the strip length. And then using some error, not necessarily percentage error, but like difference error, which is pretty okay. You wouldn't have to go and memorizing the percentage error formula. So again, general comment on this question. If you've practiced your geometry, I'd say you probably would have flew it through this question. It was pretty nice for those fond of geometry. Not necessarily me, but I know of a lot of students who really do like their geometry and would have found this question pretty handy. And then question 10 starts off with doing some inferential stats. So just the usual mean this, standard deviation this, finding a percentage, and then given a percentage to find some numerical value. And then some more probability. So I thought the only probability was that one involving the solar panels, but this one, vaguely remember this one. Bit of an odd sort of situation, but if you read through the question and sort of digested everything, then you would have actually found that a lot of this is pretty standard. So probably actually one token first time in her 5th turn, you just say over the first 4 times she didn't get anything, and then the next time after she does succeed. And the rest of it's actually pretty fine. And then some stuff involving expected value, just using some variables, which they haven't necessarily done. It's always just been find the expected value or use it to find if the expected value is like minus 50 cents or something in the case of the 2025 deferred. But overall, not actually a terrible question. And that's only an explanation, so not actually too bad. So, what are my overall thoughts on the paper? Definitely a lot nicer than paper 1. Although there were some elements which students might have found difficult, such as maybe the later parts of some of the questions, I definitely feel that this is where you're going to pick up more marks. I'd say roughly statistically. More marks are going to come from paper 2 than paper 1. Similar enough to what happened in 2023. So, yeah, that's it for the maths papers. For those who absolutely hated maths, congratulations. You don't really have to do any more sort of complicated mathematics. So we're all free now. And yeah, that's kind of normal. The only 2 exam papers I have left to review will be the physics and the applied maths once they drop. So best of luck to everyone in the rest of their exams.